It's very common in math to be asked to solve an equation. And what that entails is taking the equation and trying to find those solutions, or in this case values of x, that would make the equation true. With a quadratic equation that's been factored, like this one, it's pretty straightforward to find the solutions by setting each factor equal to 0. And when we set each of these factors equal to 0, we can obtain a solution from each factor. From the first factor, x minus 3 equals 0, we add 3 to both sides, and we end up with x is equal to positive 3. From the second factor, x plus 4 is equal to 0, we subtract 4 from both sides, and we end up with x is equal to a negative 4. So we can see that each solution is connected to a factor, but also that the signs of the solutions are opposite of what they appear in the factor, because when we want to isolate the variable and do the reverse operation to get it to the other side, that again changes the sign. So now we'd like to do the reverse process. For example, here it says write an equation if the solutions are x is equal to negative 5 or x is equal to 2/3. So this time, instead of being given the equation, we are given the solutions. And each of those solutions is connected to a factor that will go into the equation. So x is equal to negative 5 is going to give us the factor x plus 5. And we obtain this by creating a factor which is equal to 0. So in order to get 0 on the right-hand side here, we would have to add 5, and then this would eventually be equal to 0. But I'm going to put the equal 0 over here because this is not the only factor. Next, we go on to the factor that we get from the solution x is equal to positive 2/3. And again, if I wanted a factor set equal to 0, I would subtract off 2/3 from both sides, and I would get that x minus 2/3 is equal to 0. And so now we have the equation in its factored form, and we want to multiply it out to get polynomial form. So if I FOIL this out, I get these 4 terms. And the one thing that I'd like to do, in addition to combining the 2 middle terms, is I would also like to get rid of the fraction here. So I'm going to multiply both the left side and the right side times a positive 3. And again, that will eliminate the fractions. So we end up with the terms 3x squared plus 3 times 5 gives us 15x minus 3 times 2/3 gives us minus 2x, and then minus 10 is equal to 0. And finally, combining the like terms in the middle, we get our quadratic equation, 3x squared plus 13x minus 10 is equal to 0. And this technique works not only for 2 solutions to produce a quadratic equation, but it could work for any number of solutions. So if I had, for example, 4 different solutions, I could set each of those 4 solutions as a factor equal to 0, and then calculate the 4th degree equation. Next, let's take a look at an equation that's got some complex solutions. Write an equation if the solutions are x is equal to I root 3 or x is equal to negative I root 3. Just as before, we're going to set up a factor for each of the solutions, and the product of those factors will be set equal to 0. So from the first factor, which is positive I square root 3, we're going to set up the factor x minus positive I square root 3. And then from the second factor, which is negative I root 3, we'll set up the factor x minus a negative gives us plus I square root 3. And again, we will set that equal to 0. Because we have 2 binomials, we will FOIL out the terms. So x times x is going to give us x squared. Our outer terms are x times positive I root 3, so that becomes plus I root 3 times x. Our 2 inner terms, negative I root 3 times x. And our last term, we have negative times positive gives us negative. But then I times I is I squared, and I squared is equal to a negative 1. And then finally, square root 3 times square root 3 is just going to give us 3, and that's equal to 0. And so what we see is that our two middle terms, the positive I root 3x and the negative I root 3x, are going to cancel, and we end up with just two real terms. We have x squared, but minus negative gives us a positive 3, and that's equal to 0. That's a somewhat surprising result, that we would have the product of two imaginary numbers give us two real terms in our equation. But one of the things that we should realize is that because these two numbers are identical except for their signs, the factors are conjugates of each other. We have x minus I root 3, x plus I root 3. Again, that plus and minus sign being opposing produces the conjugate. And that does cause both of the terms in the binomials to be squared, again giving us a real result. So x squared plus 3 equals 0 is the final equation that we obtain from the two solutions that were given, which we sometimes will call roots.